told you to do this with a calculator. If a limit ever is on a exam on the calculator portion, please do not miss it. What do you do if you have a calculator? Like numbers, graph it. One of those two things, right? Like, what kinds of numbers would you want to plug in? 0.01. And maybe that's not close enough, so 0.0001. Is it okay just to do the positive side? Check that limit point in? No, why not? Because they could be different, and that would make the answer E, right? They aren't different, are they? Should be. I bet you're wondering how I get out without a calculator. Okay, I'm pretty sure you know this. Okay, let's look at this. I would go to the table and type in 0.001.
You just did that.
And then don't forget to use some negatives because you need some for both sides. Do y'all remember how to do that without a calculator?
Okay, yeah. So if it was like, if it was x, I was like x to 2.
Anyway, so write out the difference quotient. Do you even know what that is?
P squared minus 4xt.
No.
It's close though. Your answer.
Nobody knows difference quotient?
Now you're going to screen talk. Oh.
Have you seen this before?
Yes.
Yeah.
That is
Oh,
the difference quotient. You have to memorize it. You need to know it. You won't this time.
I do not.
No.
I like to know that.
But hey, that being said, what's wonderful about master quizzes, you make a 50 out of 50 on a test graded calculus. You sure can't complain about that, right?
Oh, is that one?
There's some skills that you have to memorize for calculus, and that's the only way I can get you to do it. It works great. That's why we had 22 guys. Any questions so far? That's the difference. Does anyone know what it is? Where it came from? Today, we are going to use the difference quotient and put a limit in front of it. For whatever crazy reason we might do that. Maybe it's a joke. If you're a pre-cal teacher, that was worth it. Maybe someday we'll figure out how. Okay. Yeah, that might be it. You're in degrees, so you're farther away. So we're going to do the exact same thing we've been doing. These limits actually aren't new limits. You probably wonder why we're doing it. And I promise there's a good reason. But for today, we're just going to practice the limits. Next chapter, you'll learn why it's so important. So, I want to find the limit as h approaches 0 of f of x plus h minus f of x all over h. You did this in pre-cal without the limit sitting in front. You do agree? But it's been a while, so I'm going to go through this really slow. If it bores you, you'll get it. So go through this really slow. The first thing I'm going to do is side note. How in the world do you do f of x plus h? So how do you do that? First of all, before we do that, how do you find f of 1? How do you find f of 10? How do you find f of a million? How do you find f of sine of x? So how do you find f of x plus h? You put x plus h where you see the x. Right? That's easy. So that's how you find f of x plus h. I'm going to go ahead and simplify this right here. Normally you can just simplify it in your big difference quotient, but just for first time around, I'm going to go ahead and simplify it here. I do want to simplify this. What do I need to do first? Do the x plus h squared, right? X plus h times x plus h. Y'all okay if I do that kind of fast? So far, so good. Nasty, but so far, so good. Distribute the 2. And in all its wonderful nastiness, there it is. Any questions? That's f of x plus h. Oh, you could combine. You might. No. But you could try. So now I want to do that thing. So I have the limit as h approaches 0 of f of x plus h. I know it's that blue thing there. I'm going to write a little bit small. That is f of x plus h. Minus f of x. Do I need the parentheses? Yes. All over h. So this is all about x. That was our side note. Normally I will not do that side note. Normally we'll just do that all together, but just for first time around. Can I do some simplification now that the red piece is there? A lot of simplification. If you did enough of these last year, you notice they really simplify nicely. I wonder why. Maybe we'll figure that out. 2x squared and the 2x squareds cancel. The negative 4x and the negative 4x cancel. And a 3 and a 3 cancel. So essentially everything in red at the top cancels. So I'm left with the limit as h approaches 0 of 4xh plus 2h squared minus 4h all over h. So now let's talk limits for a moment. How would I do this limit? What's the first thing I try? Substitution. Plug in 0. What would I get? 0 over, which means good call. More work to do. plug in, now I can plug in 0 for h. And if I plug in 0 for h now, what do I get? 4x minus 4. Because the 2h is 0, so I just get 4x minus 4. Again, at this point, we're walking through some motions. We have no idea why we're doing this. I promise it goes somewhere fun.
Those are the final.
That's 5 minutes. 4x minus 4. Why does it still have an x in it? It's not h, right? What if a limit is detected for something as one is h? So let's do another. Quick question. As far as limits go, was that anything new? No. As far as plugging in things, was that anything new? So we just combine two skills that we do. It's been a while since you did the difference coach, so we just combine those into one big skill that we don't really know how we're doing. Okay. The next one's a next one because it has a fraction. We remember those fraction limits. So this is good limit practice. We're doing some of our messy limits from a few days ago. See if you can get the setup, and I'll help. See if you can write f of x plus h minus f of x all over h. Scott, yesterday we learned horizontal and vertical. Different. Yeah. Again, if you can get this set up, I'll be happy. The f of x plus h minus f of x all over h. Limits we can do, we've been practicing those. The f of x plus h is the new thing. What is f of x plus h? Does everyone agree? That is f of x plus h. What is f of x? Before I go on, are there any questions there?
Would you need to put parentheses on x plus h?
Since it's all addition, it doesn't. Different problems are different, so if you want to be safe, you could, but when you have three things added together, it doesn't matter how you do it. Questions so far? How do you do the limit? Try plugging in 0. If you do, you get 0 over 0, which means whole, there's more work to do. What technique, just glancing at it, what technique do you think you'd go for? Common denominator. I've got fractions, so seems logical. It's a yucky common denominator because they both need each other's denominator. Just remember you cannot add something to a denominator, you have to multiply. This one needs an x plus 3, and this one needs an x plus h plus 3. So I get the limit as h approaches 0 of 4x plus 12 minus 4x minus 4h minus 12. Are y'all all okay with why those are all negative? Distribute that negative. Then on the bottom I have x plus h plus 3 times x plus 3. And if y'all don't mind, I'm going to go ahead and do that. There's 1 over h instead of divided by h. But you could do it on a different step if you wanted to. Flip that cancel, hopefully. How do we know that's going to happen? It's not magic. How do we know things are going to cancel? What did we get to begin with? When we plugged in 0 to begin with?
A hole.
A whole 0 over 0. So we know when there's a 0 over 0. Somewhere there's a factor that will cancel. We just have to find it. Most cancel. The 4x is canceled. So I'm left with negative 4h over x plus h plus 3 times x plus 3. Really quick notational note. You notice how I'm writing the limit as h approaches 0 on each step? I want to see you do the same thing. So make it look like mine looks.
If you didn't do that, oh, didn't respond. It's like a question. It didn't count.
Now, that being said, I don't think this particular problem will ever be on open response on AP. It will be on open response on your first test.
First is here.
You will have one of these on the first test, guaranteed. And any questions so far? The h's cancel, which is wonderful news. Now can I plug in 0 for h? And I get negative 4 over x plus 3 times x plus 3. Or negative 3 over x plus 3. So I gotta do it if you want to write it down. Any questions? So that's a new thing for the day for the most part. We have one more thing we're going to do. One of the things that AP will make you do a lot is pick out a graph from some information. And so we're going to practice drawing graphs given some clues. I will tell you that on these problems, there is no one single right graph. It is correct if it meets all of these qualifications. So I'm going to draw one graph that meets all of these qualifications. So I'm just going to start with what I know and go from there. And as I get them drawn, I'll kind of mark them off so I know that I've done it. F of x has 3 zeros. What does that mean? Crosses the x-axis 3 times. I'm not going to draw that yet because I don't have any idea what the shape of this graph looks like, but I'm going to mental note it needs to cross 3 times. I'll go back and cross it off later. What does it mean if f of 3 equals 0?
3 is 0.
There's a point at 3, 0. What does f of negative 2 equaling 3 mean? So these are point plotting, aren't they, so far? How do you think I'm going to grade this if it shows up on a test?
Hard.
I'm going to go through and just make sure you did every piece, right? I'm going to go make sure every piece was taken care of. F of 4 equals negative 3. If this were on a test, that'd be 3 easy points. I haven't even done calculus yet. F of 4 equals negative 3. The limit as x approaches negative 1 is 2. I'm glancing down really quick. Is there anything else about negative 1? It's the only thing it says. So if the limit as x approaches negative 1 is 2, what's the easiest way to make that happen? Just make it go through 2? Just make a continuous graph going through 2 at negative 1? We could do other things. but seems easier, right? If I have to change it, I'll change it later. But for now, I might as well just draw it right there. Notice I didn't just plot a point, because would that be enough? I need to make sure both sides have that limit. The limit as x approaches 4 is 2. Glancing down, does it say anything else about 4? So again, the easiest way to draw a limit, if I don't have any other constraints, is to just make the graph go through that point. So as x approaches 4, I get 2. Uh-oh. Why is there a little bit of a problem? There's already a point there, right? Down here? I glanced down, but I didn't glance up. So f of 4 is -3. How can I make the limit equal 2, but still have that point down there and not mess that up? I'm kind of giving you a hint by drawing that little open circle. Draw the graph around the hole, right? But leave the point down there. Look at the limits at -3. What's happening at -3? Two different numbers. What would you say, what's the mathematical term for what exists at x equals -3? Asymptote. A vertical asymptote, right? So at -3, I'm going to go ahead and draw a little dotted vertical asymptote. From the right side, it's approaching -infinity, right? So I'm going to turn that down. Okay. From the left, it's approaching positive infinity. I don't know what I want to do over here yet, so I'll just leave that arrow there. So you can see I have some gaps in my graph. So I'll have to go fill those in at the end at some point, maybe. The limit as x approaches infinity is 4. What is that? Good, I like that. Horizontal asymptote at 4. Can you see how there would be multiple correct graphs? I'm making some assumptions in the middle. As long as the pieces are taken care of there. And the limit as x approaches -infinity is 0. So what do I need to do on the other side? Horizontal asymptote at 0, right? I checked everything off but one. What's the one thing I need to finish checking off? 3 zeros. How many do I currently have? 2. I have 2. Could you have put that other 0 in a different place? Absolutely. I just sort of straight down there. So like 1, 2, 3 zeros. So I just crossed the x-axis again. I could have crossed the x-axis anywhere. I remember seeing some graphs like this on a test. So this might be on a test. And some of them would cross out here. Is that okay? It makes no difference where you cross. Except this one had to be here. Why did this one have to be here? Because it said it was. And then the other two, I got to take some liberties on how I made those happen. Any questions?
Unlike G and H, is this supposed to be X is negative?
Oh yeah, you're right. And the infinity too is awesome. I made this in Word and copied it over not long ago, so you're right. Any questions about that? That is the last new thing that you have to do. There is one more thing I want to show you. It's not in the AP Calc curriculum, but it does count on teachers in college teach it, so I just want you to be familiar. It is where the limit is sine of x over x as x approaches 0 equals 1 comes from. Remember I just said it is because the calculus professors, they probably wouldn't like that answer. So I just want to tell you about a thing called the squeeze theorem. Some textbooks will call it the sandwich theorem. And this is the algebraic place that the limits, those two special limits you learned, this is where those came from. The squeeze theorem says that if you have three functions, and one's trapped in the middle, and you find the limit of the outside two functions, and it's the same, then the limit of the middle two functions is the same. So imagine you're eating a Subway sandwich. That's why it's sometimes called the sandwich theorem. Okay, someone tell me which favorite Subway sandwich.
Chicken.
Chicken. And what kind of bread? Wheat. So I got a chicken bacon ranch sandwich on wheat bread. And I'm going to take a bite. If I get the top and bottom bread in my mouth, what also is going to go in my mouth? The chicken bacon ranch, right? Because it's in between bread. That's what this theorem says. Sure. I'll share that.
You want to try it?
I just want you to know that it exists. Okay, it takes a little algebraic work to get there, and I'm not going to do that algebraic work. I'm going to show you the picture. But looking at this picture, the black graph is sine of x over x. Would you agree that in this area, sine of x over x stays between cosine of x and the line y equals 1? Agreed? It is trapped between. Do we know the limit as x approaches 0 of cosine of x? So we can plug it in, can't we? Right, Becca? So as x approaches 0, the limit is the cosine of x is 1, right? And then as x approaches 0, what's the limit of 1? That's almost too easy of a question, isn't it? 1, right? So if these two limits are 1, what does the function in between have to have as its limit? 1. So that is the algebraic way to show that the limit is x approaches 0, sine of x over x is 1. Again, I took a couple shortcuts because I didn't prove to you that this was in between except graphically. But that's called the squeeze theorem. If you see that in college, that's what we're talking about. Any questions? All right. I have one more homework paper for you. Tomorrow, the first class homework's due at the beginning. I would love it if you got both homeworks done tomorrow, but we won't grade the other one until Friday in case any of you have really busy nights tonight. That way I'm not doubling you up. Tomorrow